Let's have a look at some mathematical operations that we can apply to arrays in MATLAB. Let's first define some matrices. So for example, let's define A as a matrix with random numbers with 2 rows and 3 columns. So A in this case will have these entries. So rand is one of these extra functions that you can use to create arrays or vectors. Let's define B as a matrix with ones with also 2 rows and 3 columns. So no surprises here. B is a 2 by 3 matrix filled with ones. And for C, let's again use some random numbers with 3 rows and 2 columns. So we have defined these 3 matrices A, B, and C. Now we can use mathematical operations on these arrays in exactly the same way as we would do following the rules of linear algebra. For instance, let's say we want to multiply one of these matrices with a scalar. For instance, let's say we want to multiply the matrix B with the scalar 2. Then the notation is simply as follows. We just take 2 times B. That's a typo, 2 times B. Similarly, the order of operations here doesn't matter, as it also does not matter in linear algebra rules whether you multiply with a scalar from the left or the right. Now we can add two arrays. So let's try to add matrices A and B, because we know this is allowed. We know that A is a 2 by 3 matrix and also B is a 2 by 3 matrix. So from linear algebra rules, A plus B is defined and is defined as the entry-wise addition of A and B. And we see indeed that A plus B has as entries simply the entries of A plus 1 for every entry. We can also do this with addition, for instance. Now, note that it is not possible, since the size of C is 3 by 2, not 2 by 3. It is not allowed to, for instance, try to calculate A plus C. And MATLAB will give indeed the answer that matrix dimensions must agree. This is not allowed from linear algebra rules. Let's look at multiplication between arrays. Now we have A 2 by 3 matrix and B a 2 by 3 matrix. So again, the matrix multiplication of A and B would probably should not be defined if we follow standard linear algebra rules. And indeed we see another error here, that there are incorrect dimensions for matrix multiplication. So the number of columns in A should match the number of rows in B, which is not the case here. It also hints us to the fact that if we want to perform an element-wise multiplication, we should not use the star operator for matrix multiplication, but use dot star for entry-wise operations. But let's look at that in a minute. What should be defined, however, is the matrix product between A and C, because A has 2 columns and C has 2 rows. No, sorry, it's the other way around. A has 3 columns, C has 3 rows, and so A is a 2 by 3 matrix, C is a 3 by 2 matrix, so the outcome should be a 2 by 2 matrix if I press enter, which is indeed the case. So for all these things, you should just follow the standard linear algebra rules, the standard mathematical linear algebra rules. Now, what if we want to multiply the individual elements of A element-wise with the individual elements of B? So in this case, this would mean we multiply this element of A with this element of B. We multiply this element of A with this element of B, which in this case is all simply equal to 1. So an element-wise multiplication between A and B here would simply yield a matrix which is identical to A. Now for that we can use the special version of the operators with this dot. So if we type A dot star B, then the outcome is indeed the entry-wise product of A and B. So, and in this case, that is equal simply to A. Now, if B were a matrix of 2's, the other way around, to get the same dimensions, the correct dimensions, then in this case we have that the entry-wise product of A and B is exactly the double of A, because every entry here is multiplied with the entry there. So that all seems to make sense. If we want to, for instance, square each of the entries of A, we can do that also by using this entry-wise power dot hat. So the hat operator for exponentiation, and the dot, we add this to indicate that it's an entry-wise operation like this. And now we see that every entry in A would be the square of the corresponding entry. So every entry in A squared is simply the square of the entry in A. And note that actually the matrix multiplication of A with itself is again not defined. So be sure to make this clear distinction whenever you're doing multiplications of arrays, whether it's a matrix multiplication following the standard linear algebra rules that you're after, or whether it's an element-wise operation that you want to be doing.